Hello everyone, today we're looking at probability and looking at the topic of possibility spaces, also known as sample space diagrams. Now, the question I've got in front of you is I'm going to flip a coin and roll a fair dice, and what I want to find is the probability of getting a tails and a 4, a tails and an even number, or a tails or an even number. Now, when you're looking at flipping a coin and rolling a dice, we need to work out how many different combinations there are when you do this. And to show this, we use what we call a sample space diagram, which enables us to list all the possible outcomes. So on the left, I'm going to show the two options when you flip a coin, which are heads and tails. When you roll a fair die, you get the numbers 1 to 6. 1, 2, 3, 4, 5, and 6. And what this enables us to do is just to see what all the combinations will be when you flip a coin and roll a die. So we can see you're going to get heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6. Or you could also get tails and 1, tails and 2, tails and 3, tails and 4, tails and 5, and then tails and 6. So these are all the different combinations which you can get, which means there are 12 possible combinations. So if I'm trying to find the probability of something occurring, the probability is that event out of the total number of possibilities. So if I'm looking for tails and a 4, the only possibility of getting tails and a 4 is 1 out of the 12 different combinations. So that is 1 out of 12. Now, if I said I want the probability of getting tails and an even number, well, we need to circle anything that is both tails and even. So T2, T4, and T6. Well, that is tails and an even number, which is 3 possibilities out of 12. Or if you want to simplify that, 1 out of 4. Finally, I've got a question here asking for the probability of getting tails or an even number. So for this, it could be tails or it could be even. Well, T1, T2, T3, T4, T5, T6, those are all tails. H2 is even, H4 is even, and H6 provides an even. So that's one or the other. That means I've got 9 different options here, which is 9 out of 12, which means the probability is the same as 3/4. So for this, what I've done is I've listed all the possible outcomes by creating this sample space diagram. And now what we're going to do from this is bring about my next question. It's a very, very common question. It's if I roll 2 dice and add the scores together, I want to find different combinations of getting, for example, a 12, a 5, a prime number, or a 10 or more. Now, a very common mistake here that I see is when people say, oh, the probability of getting a 12, but when you roll 2 dice, you can get 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which means that the probability is 1 out of 11. Very, very common misconception which people write down. Or they say 1 out of 12. But for this, we need to still create our sample space diagram. If I have a sample space diagram, I have 1, 2, 3, 4, 5, 6. That's my first dice. And my second dice going the other way, 1, 2, 3, 4, 5, and 6. If I now write down the scores when I add these values together, we can see 1 and 1 is going to make 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, and then finally 7, 8, 9, 10, 11, and 12. So what we can see here is there are actually 36 different combinations when you roll 2 dice. The least common of these are the 2 and the 12. There's only one possibility of getting a 2 or a 12. So the probability of getting a 12 is 1 out of the 36 different possibilities. Now, the next question is the probability of getting a 5. If we circle the number of ways of getting a 5, well, it could be a 4 and 1, a 2, a 3 and 2, a 2 and 3, or a 1 and 4. So that is 4 out of 36, or equivalent to 1 out of 9. Now, if we look at this, I always like to just ask what is the most common number when you roll 2 dice, and actually it's 7. There are 6 different combinations of getting the number 7. But the next question is the probability of getting a prime number. So we actually need to list our prime numbers first. 2 is a prime number over here. 3 is a prime number. I'm going to do a different color actually. So 2 is a prime number. 3 is prime. 5 is prime. 7 is prime. And then finally 11 is prime. 8, 9, 10, and not neither is 12. So the prime numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 36, which again simplifies down to 5 out of 12. Finally, the last one is the probability of getting a 10 or more. Well, 10 or more is everything to the right of this. That's 10 or more, which gives us 1, 2, 3, 4, 5, 6 out of 36, which is equal to 1/6. So what we've done there once again is drawn this sample space diagram or this possibility space diagram to show us all the different possibilities. Now I'm going to go to one final example, again a very, very common question that I see coming about when we go across this topic, and it's based around 2 different spinners. And the question has your 2 spinners and the numbers on the spinners. On the first one is 1, 2, and 5, and the second one is 1, 2, 3, and 7. And it says the product of 2 fair spinners is recorded. So product means that when you get your 2 numbers, it lands on a number, it lands on a number, it multiplies the 2 solutions. That's the value, or that's the word product. And it wants us to find, once again, the probability of getting a 7, probability of getting a 9, product of getting a prime number, probability of getting a 10 or more. So once again, we need to list out the different ways in which we can do this. So, or the different possibilities. So we can have from our first spinner 1, 2, or 5. From our second spinner, we can have 1, 2, 3, and 7. And we've said that we're trying to work out the product that is recorded. So the product that is recorded in this case is 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 7 is 7, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 7 is 14, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and 5 times 7 is 35. Now from this, there are 12 possible options that we could have, 12 possibilities. The first one says find the probability of getting a 7. Well, the only scenario where you get a 7 is over here, which is 1 out of 12. The next one is the probability of getting a 9. Well, you'll see 9 is impossible. When a probability is impossible, we get 0. It's impossible to get a 9 from this situation. We next said the probability of getting a prime number. So once again, our prime numbers for this case are going to be 2, not 1, 1 is not prime, 3, 7, and 5. Those are our different prime numbers. 1, 2, 3, 4, 5. So that gives me 5 out of 12. And then finally, the last example, or the last value, is the probability of getting a 10 or more. So if we identify the values that are 10 or more, that is only these 4 situations over here, which is 4 out of 12 or 1/3. So that is effectively the topic of possibility spaces or sample space diagrams. We've said you always need to write down the different layouts for each one, the different values, and create a table. And then from there, you can work out your different probability questions or even just general questions from these scenarios. Anyway, I hope that's made sense. If it hasn't, please leave a comment below or message me directly. Thank you very much for watching. Take care and goodbye.